Hello, welcome back to our CompTIA Security Plus exam prep series. In this series, we are going to make you perfect to make your Security Plus exam a success story. Okay, in today's video, we are diving into one of the most important domains, that is cryptography basics. By the end of this session, you will understand building blocks of encryption, hashing, PKI, and how they keep our data secure in real world. We are going to cover today symmetric, asymmetric keys, hashing essentials, digital signatures and certifications, public key infrastructure, and CIA tried in crypto. Okay. Talking about myself, I have just recently passed the CompTIA Security Plus examination with more than 850 plus marks. I will also tell you some of the tricks that you can use to get good score into the exam. Okay, so let's go to our first session. Okay, so here is encryption fundamentals. So what is symmetric versus asymmetric encryption? Okay, so in the symmetric encryption, it uses the same key for encryption and decryption, and it's fast and commonly used for bulk data like AES. So whenever you will think about the symmetric encryption, just think about it as a single key. This single key is used for both encryption and decryption. And in the case of asymmetric encryption, it uses a public key for encryption and a private key for decryption. This is slower process but provides stronger security. Examples are RSA and ECC. Okay. So whenever you are think about the asymmetric encryption, think more about security because it uses the two keys. First one is public key, which will be known to both the parties, and second one will be the private key, which will be only known to the person receiving the file or receiving the item. Okay, but it is slower than the symmetric one. Why? Because the symmetric one only contains one encryption key. And when we talk about the general data and internet, symmetric encryption is used whenever the data that is traveling is less important. Because why? Because the amount of time required is so fast. So rather than giving unimportant data lots of resources, we simply give it a symmetric encryption. Okay, so it is also widely used for the data at rest at in transit. When we think about the asymmetric encryption, so asymmetric encryption is used for the security exchange and digital signatures. We will be knowing about digital signatures in next some time. Okay, so let's go to the next part. And in case of the CompTIA Security Plus examination, you just need to focus on the concept that what is symmetric encryption, what is asymmetric encryption, and its examples. So the question might be asked, what is a they will give you options like for example, AES is which type of encryption. You will be given options like symmetric one, asymmetric one, and two others might. Okay, so you need to keep in mind that AES is a symmetric one encryption. As it, I will also give in later part of our series the questions which might actually directly come into your examination as well. So let's go about hashing. So a hash is one way function that converts data into a unique fingerprint. And the most common algorithms are EMD5 and SHA. These are algorithms that are mostly used. The key process here is integrity. That is, make sure your data isn't tampered with. Okay, so in our previous lecture I talked about the CIA triad, and in the CIA triad, the second CIA, meaning confidentiality, integrity, and availability. So that I meaning integrity, that our data has not been altered or not been changed. So we know about this when we use these two algorithms, MD5 and the SHA. So it will be a very simple one. In later parts of the course we will deep dive into hashing. On this right now we are just looking into overheads of our courses. Okay, so let's go ahead. So we will know about what are the digital signatures and certifications. Okay, so a digital signature uses asymmetric encryption and has two things to prove. First one is that the message really come from the sender, meaning authenticity. Okay, the second is that data wasn't changed in transit, that is integrity. Okay, so you can see that in the asymmetric encryption, okay, we have given, okay, so let me check where it is. uh, Digital signatures, yes, here used for secure key exchange and digital signatures. So why it is used as a digital signatures? Okay, so as I already told you that the private key is only known to the person receiving it. So whenever I am creating a encryption, okay, so I know the public key. But when if this, we will take example of a particular file. So for example, if a particular file gets lost, okay, but still the receiver will not be able to see the data inside of that particular file. The reason being he will not be having the private key. So this is the main function of using asymmetric encryption in the digital signatures. Okay, and in the CI triad, I also told you about the new concept called non-repudiation. So this non-repudiation concept also comes under the digital signatures, as the receiver cannot deny that he have received the item, and the sender also can't deny that he have sent the package. As simple as that. Okay, and these certifications are mainly issued by CS. Which certification? These digital certifications. Okay, these are bind a public key to an entity like person, organization, and they are like digital IDs issued by trusted authorities and used to verify authenticity of a website or software. So sometimes when you log in and you see that this website might not be secure, so the reason being that their certification authority has not certified them a particular certification, telling that okay, this person or this organization has fulfilled all requirement for this. Okay, I hope you get that. Okay, so whenever you see a padlock, okay, so padlock meaning that the certification is being used. When you don't see the padlock, okay, so it's simply meaning that the certifications are not being used. Okay, so let's go. Now we will go to the PKI. So what is PKI? PKI is a public key infrastructure. So whenever I say that we are using symmetric encryption, asymmetric encryption, these both contain the keys meaning public key, private key. So to manage all these keys we have the PKI, public key infrastructure. PKI is actually an entire framework that manages keys, certificates and trust. Okay, it also allows secure communication over the internet, and HTTPS uses PKI where the server provides a certificate so your browser knows it's safe. So as I told you in our certifications that if you have been assigned a certification by any of the authorities, like certification authority CA itself, the name and the company name both are same. Okay, certification authority. So the our browser will be knowing that okay, this website is secure compared to others. Okay, so in this PKI, as you could see that PKI is a system of hardware software policies and procedures to create, manage, distribute, use, store, and revoke digital certification. So it is a framework that already has been made. So we don't need to make any kind of new infrastructure. Okay, so it also enables secure communication by providing a framework of trust. So it is, as I mentioned, it is already been given. What are the key components? CS, certification authorities, registration authorities. Why? Whenever you want a new CS certification, you need to register yourself. So these are the registration authorities. Certificate revocation list. So sometimes when a particular website has been given the CS certification, meaning certified uh, by the authorities, but still they might be revoked as this if they found out that the website is a malicious or using for the malicious purposes, then they might revoke the list. And when we think about the online certification status, so what our browser does is whenever we are going on a particular website, it checks on this online certificate status protocol, yani OCSP. And if our browser found the record on the OCSP, then it automatically gets to know that okay, this website has been issued a good certificate by any of the certificate authorities. Okay, so whenever you think about the perspective of the CompTIA Security Plus examination, always think about okay, what is online certificate status protocol? It will be simple. Just look at its name. It's simple that whenever we go to any particular website, our browser checks this OCSP to verify that if a particular website is having the CS certificate or not. Hope you get it. So these are all like frameworks or the topics that we have covered from just uh, from its like definitions. We have not gone to the deep of this yet, but we will go after this next video. Okay, I have also made the one playlist for this, so you could go through them. So here we will go to the HTTPS. So HTTPS one is simple. HTTP's full form is Hypertext Transfer Protocol Secure. It is a secure version of HTTP. Okay, largely powered by PKI and cryptography. As I mentioned, what is PKI? PKI is a public key infrastructure, and it is the rules, the policies, the procedures has been already been made. Okay, so it's not like we need to configure anything. No, they are already in place. We are just using it knowing unknowingly. Okay, as I also explain the what is cryptography. Okay, so in case of HTTP, we use the different port numbers. Like in HTTP, we use the port number 80, and the HTTPS we use the port number called 443. Okay, so these are different ports. When we connect to an HTTP website, your browser uses PKI to verify the website digital certifications. Okay, as I told you, whenever we go on a particular website, our browser checks for the PKI. So and PKI are the already associated the procedures and policies. So what he will do, he will first go to, let's check, he will first go to online certificate status protocol to check if your certification is still valid. If he does not found any certification, then he will give us a warning. Okay, so this site might not be in a good position or not a secure one. Okay, so this process actually ensures that we are communicating with a legitimate server, not an imposter. Because whenever one company or a person registers itself with a digital certificate, so they get their digital IDs, and these digital IDs are impossible to replicate as these are entities which are already registered. So whenever our browser goes to these sites, okay, like OSCP, etc. Then it directly gives the ID number. So he will understood, he meaning their browser will understood that if, okay, so if this particular website is having certification or not, having the right encryption or not, and then we could easily be proceed with our website, okay. And after the verification, that is verified that okay, this website contains the CA certification, it has been not been revoked, then a secure encrypted tunnel is established using combination of asymmetric for key exchange and symmetric for data transfer. As I mentioned you, that the all the data that is not necessary or less important will be encrypted using the symmetric one, and all the data, as you could think of, the key data will be more important, as this key, as these keys will be used to decrypt the information or encrypt the information as well. So this is more important data that will be encrypted using the asymmetric one, okay. So this protects our data from eavesdropping and tampering, okay. So these are the simple steps. And as I already told you what is CI trade, so I am again just giving you an overview what is CI trade. We have already discussed this in our previous video. So when we think about cryptography and the CIA trade, just CIA trade meaning confidentiality, integrity, and authenticity. So confidentiality meaning encryption. Encryption meaning two parts. First part will be symmetric and second is asymmetric one. What is integrity? Integrity meaning guarantee that data not has been altered or tampered with, okay. And it is achieved by hashing and digital signature. So as I told you, the hashing we use like MD5 algorithm, and whenever a slight or like minor changes happen to a file, the overall hash directly changes by a major portion. So we could just identify that okay, the our file has lost its integrity and it has been altered. When we think about the authenticity, it comes that it verifies the identity of user or systems, okay, achieved through digital signatures and certifications. As I told you, whenever we go onto the particular website using our browser, so our browser tries to find the authenticity of a particular website by using to locate its certifications, that okay, is this is this a legit site or it is an imposted, okay. So, and the fourth part, which is a new one, is non-repudiation. What is non-repudiation? Non-repudiation means that if a particular, for example, if a particular person has sent an email to a company telling, okay, so these are the, for example, like this is bill for my services, okay, and so the company will also have the record for the same, and whenever the person will deny, okay, I didn't send you any bill, etc., or any kind of that, so company will have the signatures and digital certifications of the sender. So nor the person nor the company could deny the claim that they have been received the particular items or the particular emails. So that's why non-repudiation is also included in this triad. Okay, so let's so now from this all our small lecture, the key takeaways are simple. Encryption types are two. First one is symmetric one, second is asymmetric one. Symmetric ones is single key, fast and key distribution challenge. Okay, the asymmetric one is public private key pair, meaning it has two key pairs, okay. One key pair in which there are two keys. It is slower and solves key distribution. The second is hashing. It is one way function MDSSA to ensure the data integrity. As I mentioned, it detects changes. Third is digital signatures, provide authentication, integrity, and non-repudiation using sender's private key. Okay. The fourth one is digital certificates and PKI. bind public keys to identifies. Okay, as I mentioned, it is in a non-repudiation as well, the digital certificates. In PKI, like public key infrastructure, manages certificate lifecycle and enables resource communication. That is HTTPS. PKI meaning in the PKI, all the infrastructure, all the policies, all the procedures has been already been written and already been implemented. So we just need to study some of it. Actually, it is already working. So whenever we search and whenever we build something in the back end on the internet, the PK is already working. Okay. So in case of our last CI tried, so in CI tried, cryptography supports confidentiality, meaning encryption. Integrity supports hashing digital signatures, and authenticity supports digital signatures and certificates. So whenever you think about cryptography, think about confidentiality, encryption. In case of integrity, think about hashing digital signatures. And in the authenticity, think about digital signatures and certification. So in this video, thank you for now. Let's hope that you like this video, and we will we will see you in our next video, and hope that you are on a path to achieve your certification as well. Okay, so thank you so much.